The landscaping code for this project involves using a function that firstly creates plots of land that are randomized according to the sizes of the houses generated. The plotting algorithm for landscaping section simply plots a rectangular piece of land that extends vertically by 7 units to account for other structures such as a fenced off swimming pool and wells. The code checks for which direction to further extend the plot of land created, and this is based on where the road is located. Furthermore, the code uses this extra piece of land to plot randomly chosen swimming pools or wells using the backyard pool and well structure functions within the landscaping class. Landscaping is implemented using object oriented programming, and this is done by creating multiple functions under the landscaping class to be used in the main village.py file. This allows for the code to be more modulated and separated from the main function.
The code for creating the road uses a function that makes use of for loops that iterate continuously and correspondingly build the roads. The condition will stop iterating and creating road if the inner for loops meet the distance of the road and when the outer for loops finish traversing sideways, contributing to the road's width. There are four of these linearly traversing algorithms, each for the directions north, east, south, and west. The South Sea, North Sea, East Sea, and West Sea iterate in their corresponding directions from the house until reaching the end. It iterates through the use of a while loop, and the road it makes is also made of brick, as the other road making algorithm does. This algorithm uses a method called getRealHeight, which returns the height of the block that the road should iteratively build at. This avoids the risk of creating the connecting roads from the house to the main road on top of trees. The connect house uses an if statement to ensure the road is being built towards the main road. It assigns each direction to a function previously described, also passing the x, y, and z values to them. The road creating code is all confined in a road class, utilizing object-oriented programming. This allows for modulated code as there are multiple functionalities to creating the road, separating them all in one class and one object when being used in the main village file. For our additional village structures, we created a variety of outdoor structures such as street lamps, benches, tabletops, barbecue grills, and chairs. A street lamp generator was created to randomize the styles and materials in which the lamps were built. The streetlight materials were stored in a dictionary with different themes, and a theme would be randomly selected with those blocks set with those parameters. The generator accepts a direction and a side to dynamically point the street lamps toward the footpath by adding certain values to the light placement. Our street items also had a generator method that built a randomly selected structure based on the coordinates they were given. The coordinates for all of the structures were randomized by following the main road and placing them arbitrarily far from the previous placement, and avoids building over the footpaths by skipping areas near brick blocks. We randomize the heights by placing them on the ground, using an adapted version of the getHeight method that ignores trees and plants. This helps with a smoother footpath and less interruptions by trees and realistic structure placement.
For the Windows house components for the house, we decided to take a pure randomization approach that builds windows randomly across all four directions, north, east, south, west. Furthermore, this algorithm also uses the orientation/position of the door so it can ensure no windows are being placed in front of the door. The data structure that was used for this algorithm was a set data structure. We incorporated the set into the algorithm by making a function that keeps adding values to the set till the specified length is reached. This length was determined to be the amount of windows we are going to build. Using a set allowed us to store unique values and thus prevent any overlaps from occurring. Essentially, the algorithm works in one main part and two subparts. The main part records all the unique values between 0, length minus 1, and the amount of random windows to be built on the x-axis by calling the set function and storing the return value. The algorithm then starts by iterating through the set and checks if the orientation of the door is between east or west or north or south. If the east or west, then it further checks specifically if it's east or west, and accordingly the algorithm plots windows either on the zeroth width or the maximum house width, and it plots the windows and calls the set function again to record all the values between the zeroth length and the maximum length and plots windows again. Meanwhile, when it's plotting windows, the algorithm keeps checking if the window block is on the door block to check that the windows don't build in front of the door or on the door. If it is, then it's randomized again in a while loop. The algorithm works vice versa for north to south direction.
The house module was split into two classes, which was a custom-made random class and the main house class. The random class contains a constructor that initializes a variety of variables, such as choosing between a 1 or 2 story house, determining the height of the roof, or randomizing the length and width of our houses. To evidently show the requirement of rectangular plots, I used a while loop that keeps iterating until the range between the value of the length and width is greater than or equal to 2. Also implemented within the random class, a simple return method to help organize what values we will use when building the house. The house class also starts with a constructor that contains a randomized selection of house materials to create more variation in our overall village generation. The substantial use of object-oriented programming proved beneficial in organizing the code into separate methods, which in turn I ultimately decided to build the first and second level floors as separate entities. I also utilized cardinal directions, especially between north and south, as this allowed the house to face our main centralized pathway. In my code, I made heavy use of conditional statements to allow randomness to be fully harnessed in our house object-oriented design. For example, with our pool placement, depending on the cardinal directionality and the random choice functionality, the pool's position relative to the house will vary. Not only that, but similar to our houses, we also randomize the length and width of our pools.